Hi everyone. Let's take a look at number 5 on page 179. Determine the critical points for each function. Determine whether the critical point is a local maximum or minimum, and whether or not the tangent is parallel to the horizontal axis. Part A, h of x equals to negative 6x cubed plus 18x squared plus 3. Step number 1, find the critical point by finding the first derivative. When you apply the power rule and you take the derivative of negative 6x cubed, that's going to be negative 18x squared, plus when you take the derivative of 18x squared, that's going to be 36x, and when you take the derivative of a constant, that's going to be 0. Step number 2, I'm going to set the derivative to 0 to solve for the x values of the critical point. So notice on the right hand side, I'm just going to copy as is. And in order to solve for x, we're thinking about factoring. First, we're going to take a common factor of negative 18x. In the brackets, it's going to be x minus 2. This means if I draw a line in the middle, divide this into two different cases. In the first case, negative 18x equals to 0. And in the second case, x minus 2 equals to 0. If I start with the second case first, x equals to 2. Go back to the first case. The opposite of multiplying by negative 18 is to divide by negative 18. X equals to 0. Now, the habit you want to form is to find the critical points, not just the critical numbers. And the major difference between points and numbers is that points means you want to find the location. You want to find the coordinate. So what I'm going to do is I'm going to plug in these numbers back in. So if I plug 2 into the original function, this means the corresponding y value is going to be h of 2, which is negative 6 times 2 to the power of 3 plus 18 times 2 to the power of 2 plus 3. And again, you can take the calculator, or I'm going to show you some mental math. Now, when you work this out, it's going to be negative 6 times 8 plus 18 times 4 plus 3. That's going to be 27. So again, one critical point is going to be located at 227. Now, if I go back and I look at the first point, again, I can plug it back in. And this one's a little bit faster because if you really look at it, h of 0 equals to, and I hope you can see what I see, I'm plugging in 0 back into here and here. So both of those terms are going to be 0 plus 3, which basically means it's going to be 3. So the second critical point is going to be 0, 3. Now, don't forget the second part of the question here. So it's not just determine the critical points, but it's also determine whether the critical point is a local maximum or minimum. Now again, there are a couple ways of doing this. You can use the first derivative test, or you can use the second derivative test, or you can use the skills of graphing a polynomial. So I'm just going to show you one method here. And again, there are many ways of doing this. I'm going to show you something called the second derivative test. And this means we're going to plug in the critical point into the second derivative. And depending on the outcome, we can figure out if it's going to be a maximum or a minimum. So again, second derivative test. This means I'm going to continue with h prime and find h double prime. So again, from here, I can tell if h prime is going to be negative 18x squared plus 36x. The second derivative, it's going to be negative 36 times x plus 36. Again, all I'm going to do is I'm going to plug in the critical points. Now, notice the first critical point. Again, let's highlight this for you. The first critical point that we have found is going to be 0. When I plug in h prime of 0, that's going to be negative 36 times 0 plus 36, which is basically a positive number. Now, this tells you the following. If the second derivative is positive, this means it's going to be concave up. And of course, if it's going to be concave up, this tells you that this critical point is going to be a minimum. So again, minimum means concave up. So therefore, 0, 3 is a minimum. So likewise, I can go through the same process for the second critical number, which is x equal to 2. So again, I'm going to go back and trace this with you. The other point is going to be x equal to 2. I plug it back in, and again, if you take a calculator and you work it out, that's negative 72 plus 36, which is basically negative 36 or a negative number. Again, the fact that the second derivative is a negative number, this means this is going to be concave down. And of course, concave down implies is going to be a maximum. So you could write down, therefore, the critical point 227 is a maximum. Again, we're still not done yet. If you go back to the last part, it says determine whether the critical point is a local max or min, and this last piece, whether or not the tangent is parallel to the horizontal axis. So here's the short answer. Because we found the maximum and the minimum, and this is a polynomial, so the short answer is the tangent is parallel to the horizontal axis for both, but I want to over deliver by activating a dual mindset with you. So I am going to write down therefore tangent is parallel to the horizontal axis for both. But I am going to over deliver by graphing this with you so you can see what I see. Now again, this goes back a little bit to MHF4U, grade 12 advanced functions, which is a course ideally you've taken prior to this one, of course. And here's the major concept. Now, this is just a rough sketch, so by no means is this perfectly accurate, but it's good enough in terms of the graph that we're given. So for example, if I look at the points that we have found, which are 0, 3, which we have denoted as a minimum, and this other point, 227, which we denoted as a maximum. Again, the question becomes, is this tangent parallel to the horizontal axis? Now again, think about the function, right? We're trying to graph y equal to negative 6x cubed plus 18x squared plus 3. So this is a negative leading coefficient. And notice that the exponent, or the degree I should say, which is the largest exponent, that's going to be odd. So you're thinking about negative odd. And negative odd signals to you when you're graphing a polynomial. Again, this is a grade 12 advanced function skill set. The end behavior is going to go from quadrant number 2 all the way to quadrant number 4. So that means it's going to go somewhere roughly like that. Then it's going to go roughly somewhere like that. Again, it's not a perfect graph, but it's good enough in terms of the question at hand. So if I go back, this last piece right here that I highlighted in blue, whether or not the tangent is parallel to the horizontal axis, we did conclude that it is. But more importantly, the reason why it is parallel for both cases is because if you go to the graph, this is the horizontal axis. And if you draw a tangent to the maximum and a tangent to the minimum, notice all three lines are parallel. And this is how you know. I hope this makes sense.